This is the final session here, continuing the theme of what fusion needs. This is a really important subject that I'm sure you people at home and people in the audience will love to hear more about, which is the regulatory framework and the right regulatory framework for success. So now I'm going to hand you over to Sally Forbes, who's our chair from the UK Atomic Energy Authority, to take the session forward. Thank you.
Thank you very much. Yes, so what does fusion need? It is going to need regulation, and that's why we're all here with you today. So I'd like to introduce the panel. First, Richard Broughton from the HSE, if you'd like to just explain your role.
Yes, thanks, Sally. Richard Broughton, Health and Safety Executive. I'm currently the head of radiation policy within HSE. I'm career HC largely, worked there for most of my time. Had a number of policy roles over the years. I'm a policy generalist, a regulatory generalist. I've had responsibility in the past for asbestos management, young person safety and risk management for quite some time. The Health and Safety Executive is the GB regulator for workplace health and safety and is responsible for all industrial activity other than the licensed nuclear sector and the railways. We're a GB regulator, a sister organisation, the Health and Safety Executive for Northern Ireland. Sorry, not strictly correct, entirely separate, regulates in Northern Ireland, but under the same framework.
Thank you. And secondly, Sachin, Desai from Helion, and we're very pleased that you've travelled from the States over this event this week.
Oh, well, thank you very much for having me. I got to say, it's always fun to go to London. On Sunday, I did the Peppa Pig tour with my family. And then, but you know, every time I'm here, I also get a chance to see the industrial dynamism of this country, and I know it's doing fantastic things in fusion. A little bit about myself real quick. I've pursued my career in clean energy development and deployment. Started it at the US Nuclear Regulatory Commission and then worked in the private sector helping a number of clean energy technologies deploy faster, but also safer and better. Jumped onto fusion when I had a chance to learn of all the advancements it's been making in the space, because I've seen deployment from different perspectives, and I thought there's a lot of lessons learned that can be applied here, because there's beyond just getting the technology right, there's a number of challenges to overcome that we can overcome to get this technology on the grid. And so as General Counsel of Helion, I handle everything that comes in the door sometimes, but one of the things I'm taking a lot of pride in is trying to work to develop the best path forward for fusion to deploy. And a little bit about Helion real quick. We're taking a slightly different approach to fusion than you may have seen in some of the other panels. Instead of confining a plasma ring, we actually take two plasmas, we accelerate them together, compress them, and then directly recapture the energy from the compressed plasma as it expands. We have a direct energy recapture mechanism, so we don't have to use a steam turbine to convert fusion energy into electricity. Our notable goal is that we've recently raised $500 million based off some past really successful experiments with prior generation devices, and are looking to demonstrate net electricity from fusion by 2024, with the goal to put a device on the grid within a decade, which of course then requires us to figure out the regulatory framework, among other things, really soon.
Thank you, Sachin. And finally on to Mike Webley from the Environment Agency.
Yep, so hi, I'm Mike Webley from the Environment Agency, as Sally says. I'm a senior advisor within the Environment Agency, and we have a team within the Environment Agency. We're looking to kind of build capability and capacity to regulate advanced nuclear technologies, which includes fusion. Within the Environment Agency, like I said, we've been working with industry to kind of build our knowledge, and also working with other regulators, for example, Richard in the HSE. We've got a wealth of experience regulating facilities that are already working. So we've been regulating JET for a number of years, and we've also had discussions with Tokamak Energy, First Light Fusion, to learn more about their technologies and how we can regulate them appropriately.
Thank you very much, everybody. Those of you that have been in the sessions today have probably already heard people asking questions about regulation, about safety and environment. So I think I'd just like to kick off with, why is there so much discussion about regulation in the fusion industry? So perhaps just to explain to us what the hazards are related to fusion. So perhaps if we start with the safety-related hazards.
Thanks, Sally. I mean, I think I might wind back and just touch on, why we actually do need to regulate and not just fusion. But we live in, a time of rapid technological advance and if you pardon the pun, quite a fissile public discourse. And so part of regulation is sort of engendering public acceptance, public reassurance and public trust. The public often can't make risk-based decisions, for themselves. And also sometimes cannot avoid risks that they would not otherwise want to run. And so an established regulatory framework with a trusted regulatory bodies is part of engendering that trust. At a more prosaic level, a fusion technology, experimental facilities, prototype plants and operational plants will be work activity. And work activity is regulated, across the world, and duty holders, employers, are given, have clear expectations in law to manage the risks of harm to their employees, but also to others. And certainly in respect of GB, the framework is largely hazard agnostic. It all flows from primary statute and a duty to control all risks. And that is in respect of all hazards. And so in respect of fusion, clearly, the ionizing radiation hazard is one significant hazard. There's also the non-ionizing radiation hazard through the use of lasers or electromagnetic fields. But then there's all other workplace hazards around the use of electricity, pressure systems, exposures to substances that may be hazardous to health. Those are all regulated, those all can cause harm, and employers are entrusted to do that and manage that and held to account by regulatory authorities.
Thank you. So what about the environmental side as well? We're very keen to protect the environment as well as protecting people.
Yeah, I mean, as the environmental regulator in England, we're interested in the impact of the fusion facilities on the public and the environment. So when we're discussing what the industry is doing, we're interested to hear about how the optimization of their processes and also the material choices to make sure that the actual discharges from gaseous, liquid and the solid waste produced are minimized as much as possible. So we're looking about how best available techniques is applied, so what choices are being made to kind of minimize those discharges and waste. I mean, in the fusion industries, we're very aware that the high energy neutrons that are released from the plasma, how they can activate materials. So we're interested about how those materials that come out of the facilities are managed, how they're kind of the wastes are mitigated to ensure that what actually goes for disposal is minimized. So we're interested about how vendors and operators are applying, for example, the waste management hierarchy, which starts with prevention, minimization, and the last choice is disposal. I mean, some of the work that's gone on at UKAEA, looking at the detritiation facilities, where they've got some of the intermediate level waste that they're detritiating, and that there's like a 98% success rate taking that to low level waste. That's good. That's good practice that we're interested to hear about, and we want to hear how other vendors are kind of applying those techniques to minimise discharges and waste.
So Sachin, we've heard a lot today about the diversity of technologies in fusion. Perhaps you could just sort of say what features from safety and environment might relate to different types of fusion technology?
And you're asking just how different technologies might have different types of hazards?
Yeah.
Sure. Well, I think I'll just take a step back too and just note that on the need for regulation, we live in where I live, I need a permit to build a picket fence. And so anything that can emit a large amount of energy is going to have hazards and risks that need to be accommodated and then dealt with and minimized to all extent possible. So, one thing we're really proud of at Helion is we're very upfront and engaged on the regulatory discussion, because not only do we need to address those hazards to make sure we can deploy, but we need to have public acceptance. We're talking about deploying, I'll get to the answer real quick, but we're talking about deploying 3 terawatts of clean energy in order to eliminate or replace fossil fuel usage. That comes out, if you do the math, to roughly a gigawatt a day at certain timescales. In order to have a gigawatt a day of fusion deploying on the grid, if fusion is the technology that has the energy density and mass manufacturability to deploy at that scale, we need broad public acceptance. Right? You can't deploy a gigawatt a day of any sort of energy technology without broad public acceptance. And in order to have that, we need to have a solid regulatory framework that's diverse and outcomes oriented. And so we need to have a framework that can handle different types of hazards, because there's incredible diversity in this field. It might have come up earlier, but for those that don't know, there's like two to maybe now 3 dozen different fusion companies out there that are pursuing very different approaches to fusion. I briefly mentioned in mine how we accelerate plasmas in a plasma accelerator type device. There's all sorts of different approaches. We use a different fuel, and I think around the different fuels, you'll see different types of issues. If you use deuterium-tritium fuel as your fusion energy source, you have to work with tritium, which is a radioactive material. You have to breed it in a lithium blanket around this device, and so you have to manage that type of hazard. For us, we use deuterium and helium as a fuel, but we produce tritium as a byproduct. And all of us essentially produce neutron radiation, which then you have to handle it. For a DT device, and I can't speak for DT devices, not working for one of them, but the DT device, you have to manage that kind of lithium breeding blanket system. You have to manage the essentially recycling process. For us, instead, we have to build a wall around our device. We call it a vault that makes sure that neutron radiation doesn't get past the wall. And then we have to have a really secure storage system, because we'll be accumulating tritium and actually storing it, because tritium decays into helium-3, which is one of our fuel sources. So we have a very different approach to managing risk. But in the end, it all really comes down to 2 types of risks, I think. One is operational. When you run, you emit ionizing radiation, like in multiple different types of energy sources, and you have to manage that risk. And then if you have an off-normal incident or something bad happens, you have to make sure that you're containing the radioactive materials that are involved so they don't spread past to workers and then to the public. And that can be relatively outcomes-oriented, despite the fact that there's huge diversity in the technology.
Okay, thank you. So I think we've heard there that there aren't particularly any new hazards individually, but what we've got is the combination of radiological and industrial hazards is something a bit different for this technology. So developing a regulatory framework has been very important over the past couple of years for those nations that are looking to develop large fusion programs. So perhaps now we can just sort of find out what's been going on both in the UK and the US. Perhaps, Mike, if you want to start with what we've been doing in the UK for the past couple of years on fusion regulation.
Yeah, there's been a lot of developments, to tell the truth. I mean, back in May 21, there was a Regulatory Horizons report about fusion energy, which one of the recommendations was kind of an evolution of the regulatory approach or framework to fusion energy. So following that, in October 21, the government launched a fusion strategy, all about being the global lead for fusion energy, which is really good, and it shows a real interest from the government in fusion. Alongside that, the government launched a consultation, so that was getting input from the public, industry and other stakeholders on our regulatory approach to fusion, and that was on the back of a green paper about the regulatory approach to fusion. So we inputted into that consultation, and then the results and the outcome of that consultation came out in June of this year. And the output from that consultation was that the regulatory approach, which is in existence, so that's with the HSC as a safety regulator and the Environment Agency and the devolved environmental regulators as the environmental regulation, would continue. And it would be considered not a nuclear installation. So there's a number of recommendations that have come out of that consultation, which are for the government and also for us as regulators. And some of the work we're doing is to kind of build capability and capacity within the regulatory world, and also to kind of develop and evolve a kind of a pre-engagement process. So that's kind of a good kind of regulatory safe space, almost like a sandboxing environment for regulators to talk to industry, to understand the risks to the regulators and the risks to the operators. So there's in the last couple of years, there's been quite a large move in the UK, and we've kind of been almost like seen as internationally as almost like leading the way when it comes to understanding our regulatory approach to fusion.
Yes, I think the work in the UK has been at the forefront of that regulatory framework. So, Richard, what kind of things need to happen now? We've made the first decision, but that's just the start of a journey.
Well, that's right. Yeah, the government consultation and green paper resulted in the current framework being judged broadly fit for purpose. However, that doesn't mean the current framework is fixed and immutable. The government response that accompanied the decision did make some recommendations for considering the need for guidance in respect of fusion operations, to think about regulatory pre-engagement, which doesn't routinely occur within the sort of radiological sphere at the moment, as opposed to the civil nuclear sphere. And the regulators are, actively now considering these. I think we recognise that we are on a timeline from A to B, and that when we consider the regulatory framework and the changes, we need to understand at what point we ramp up or ramp down any interventions we might choose. It's important, I think, to recognise that the regulatory framework isn't just about boots on the ground inspection. It is a body of legislation, both primary statute and supporting regulations specific to hazards. It's operational policy by the regulator, guidance that is out there currently, both statutory and non-statutory, and other miscellaneous aspects that a regulator can use. That needs to reflect emerging understanding of hazard and risk within fusion as it transitions to operational plans, and the various types of processes that lead to fusion, and then the complex nature of any facility in how those hazards and risks come together. And the role of the regulator through that is to use its scientific expertise, its policy expertise, and its operational expertise to intervene as appropriate and at the right time in full engagement with the industry, while also working with society at large to gain their acceptance.
So Sachin, obviously you're not with a regulator, but the US has had a couple of years of very public and industry engagement. Perhaps you could just briefly explain the situation in the US?
Absolutely, and please let me know if I should move into a different part of it. But so over the past couple of years, the NRC is engaged in its own consultation type process through public meetings and various submissions. The US Nuclear Regulatory Commission, which is essentially the plenary regulator of radioactive materials and nuclear fission reactors, was tasked by Congress to actually come up with a framework for fusion partly because of the excitement in this industry. And so after about 6 public meetings, a couple of years of analysis, they're actually on the verge right now, it's a very pivotal point, with starting with their initial recommendation for how fusion should be regulated. The NRC staff next week probably will issue what they call an options paper to the commission, which has the staff's recommendation for how fusion should be regulated, and then the commission will make a decision 3 to 6 months approximately thereafter. And the big question is not, like, there's a lot more to do after this initial choice, but the big question right now is how fusion should be regulated. Should you try to build a framework that's off of the approach for regulating industrial facilities and other industrial systems that use radioactive materials, which is actually very similar largely to the UKAEA approach right now, a UK approach right now? Or should you kind of just throw fusion into like a fission framework or some other pre-existing framework? In public meetings, the NRC staff recently has stated that their initial interest is in putting fusion devices in a new framework, so going with the former, building off of the approach that applies to just regular holders of radioactive material, which is a diverse group of facilities. But again, and that will take a couple months to play out. We're right at a pivotal point where that decision is going to be held. But as soon as that happens, then we're really off to the races, because the NRC is going to have to it's going to start with the limited rulemaking to develop the regulations for licensing first fusion devices, working with states. In the United States, sometimes NRC licensing authority can be delegated by states, where the NRC sets the framework and the rules of the road, and states do the licensing work. So there'll be a lot of action going on over the next few years just to get the basic regulations in place, and then it'll continue as the industry grows.
So from your point of view as somebody in the industry, how can you help build that capability within regulators sort of to help develop that in the future?
Great question. I think that there's a lot that we can do. And like I said before, we have very ambitious goals for this industry in the fight against climate change, so we need to have public acceptance. We need to do what we can to make sure that the community writ large is ready for this technology. We can't just keep it all to ourselves and figure out, and just hope people will license it in the future. We've had some initial engagement, and actually states. So right now, fusion devices are regulated by states as particle accelerators. All fusion devices, fun fact, all fusion devices are actually derivatives of particle accelerator technology and have a very similar set of safety considerations when you get into it, but they're different still, they're bigger. And so, we're getting questions from state regulators about how do you manage neutron radiation at these certain energy levels. We've never dealt with this type of radiation. We have dealt with other types of ionizing radiation, but this is a little different. How do we deal with tritium at this scale? We've certainly dealt with every other type of radioactive material in the periodic table, but we haven't dealt with tritium at the quantities you're talking about. So it's not like they're unfamiliar with this technology, but we need to do more to see how you would deal with it at a commercial level. And then again, a little more on understanding what are the hazards, what's fusion most similar to, so we can start taking tools from that framework and building off of there.
So Richard, from the other side as a regulator, how are you sort of aiming to build up your capabilities?
Well, I think it's very similar, and the last point you made, Sachin, is I think quite relevant. The HSC has a lot of experience in regulating very complex industrial facilities, the offshore oil installations, onshore distribution, chemical major hazards. The approach there of barriers to control, of multidisciplinary teams of inspectors, and I'll use this word advisedly because it carries a particular legal connotation, the use of safety cases and assessments and stop-go decisions is something that we can use and take and learn from and then apply to fusion as, if appropriate, and as the understanding of the hazards and associated risks develop, because we can be pretty confident at the moment, having a good stab at what the hazards associated with experimental facilities are, and then conject a development to power plant facilities. But during that journey, things become much more complex, and so with that come a more complex, regulatory expectations. So it's part of understanding hazard, part of understanding risk, building up capability through that, and then taking what we learn from that from other parts of HSC's functions.
Likewise, Mike, for the Environment Agency to kind of upskill?
Yeah, I mean, we've had some quite interesting tours. So back in April, we did a bit of a fusion road trip. So we came to Culham to have a look around the jet and mast and have a chat to some of the kind of technical people at UKAEA to learn about how the tritium handling, like detritiation and materials management and those sort of challenges. So that was really interesting. We also had a look around Tokamak Energy to see their ST40 reactor facility, and that they're actually going through some maintenance. So we got really up close and could see that, and that was really interesting. And also to hear about their kind of like high temperature facility that they're going to be designing in the future. We also had a look around First Light Fusion to hear about their inertia confinement technology. So those sort of tours and talking to the experts at the different facilities was really interesting, and it really helped build our knowledge and understanding of what's going on. And we're also looking to arrange another visit to UKAEA in November for a couple of mornings and to discuss some more technical topics to kind of grow our knowledge some more. And I think some of the presentations that were in a recent fusion industry school, I think we've kind of highlighted those as being really interesting topics for us to learn more about. So I think, like I said, we can go to courses and you can read online, but to actually talk to the experts and understand the challenges and the gaps in our knowledge, it really helps us build our capability and capacity.
Great, thanks. Yeah, I think we have to grow together as an industry and not be on sides for that. Moving to a different area, again, what we've heard today is a lot about the international aspects of fusion, the international projects, the international collaborations. But how important is international engagement in regards to the regulatory framework? Mike, I'll perhaps pick you again for that.
Yeah, I think international collaboration is really important because you can learn so much from international regulators. We've had discussions with the CNSC, so the Canadian regulators, to understand how they're approaching fusion regulation. And we're looking to continue those engagements with them to share kind of best practice on our regulatory approach and understand what they're doing and what facilities that they're interacting with. We're also looking to set up engagements with the US NRC to discuss their work, and also ASN in France to discuss the regulatory approaches there. At a recent IEA meeting in Vienna, we spent a week talking to those regulators. So we've built those kind of networking, we've built those engagements, and kind of we want to build on those. So, for example, if we're assessing a certain design, we can share our assessments and share our thoughts on that. And so it's a kind of where to share regulatory knowledge between the regulators.
So I guess from a developer and private company, what's your kind of view on international cooperation for regulation?
I would agree that I think it's extremely important, and I would say our perspective is for two reasons. One is, I think I'll just hit this on the head again, it's if we want to deploy at the scales that Fusion is talking about deploying and is capable of deploying, we can't just deploy in one country, no matter what country that is. We need to start laying the groundwork now for a framework that can apply across the world. And it's possible. We see that with airplanes, right? You can get on an airplane in Detroit and end up in London or Shanghai or anywhere, and it's the same airplane built by the same company, flown by probably the same group of people. But we don't need to get I'd say with international harmonization, we don't need to get every single word to be the same between all the regulators, but there are core concepts that we should strive to seek alignment on early. For example, one of which is, do we treat fusion devices and build a framework around fusion based on the industrial facility model that certainly we believe is apt, or do we do something else or fit it into an existing framework? I think that's going to be a really key question, and if we can reach alignment there, then we can all grow together as a planet on embracing fusion. And second is, I think there are just some questions that the international regulators, speaking of diversity, look at differently than the domestic regulators. They're going to look at things from a more holistic aspect. They're going to look at it from how does it affect countries that might have different types of skills for regulating versus other countries with more skills or experience regulating. And so it's just really interesting engagement that way.
Richard, anything you'd like to add with your international engagement?
No, just a couple of observations. I agree entirely with what's been said. I think it's. I would just emphasise the importance of ensuring that whatever expectations are set internationally, so far as we can, they should be able to be reflected within current, national arrangements, whatever they may be. So that's the language, if we can call it that has just been mentioned. So for example, an appropriate regulatory framework may set expectations for regulatory engagement between developers and the regulator, and there may be some expectations of provision and information and oversight and sign off on particular material that is required. And so if that is phrased as licensing in the UK context, that has a particular connotation that sits it firmly within the FUSION sphere. If it is an authorization approach, a neutral term, it perhaps then would fit with those frameworks in other countries where licensing doesn't fix it in a particular framework, but something else is used, such as, in the UK context, consent to practice using ionising radiation, or even permissioning if we were to go down that route. So I think it's important that it facilitates national authorities rather than inhibits them.
Thank you. I think one thing I'll touch on before we hand over to questions is I think one of the most important words for fusion is innovation. Perhaps not something that you normally associate with regulation, but perhaps start with you, Sachin. How important is it that a regulatory framework can deal with an innovative new technology?
Yeah, absolutely. I think it's important to deal with innovation or to embrace innovation in developing regulations because there's incredible diversity in this field. We have approaches that you could look at two devices and they share a lot of fundamental similarities, but you wouldn't even know one of them. If you spent your life working in one of these devices, you wouldn't know the other device is a fusion device. Right? There's this incredible diversity. And so that's part of innovation. Right? Diversity is a generator and a product of innovation. So we need to, it's almost inherent. If we're going to look at the fusion industry and regulating that we have to deal with innovation. And the second is, we need to think about different ways, long-term, as fusion scales, we need to start thinking of different ways of licensing writ large. If we want to, again, deploy a gigawatt a day of fusion, we need to think of authorizations, permissions, that can allow scalability or approval of different designs. And then that design is made in a factory and then can be built and deployed more broadly or more easily because you've had a really rigorous review up front, like airplanes. And I think that's going to be another element of regulatory innovation that we'll see over the decades as fusion takes off.
So, Richard, how does the current regulation or development of it already account for dealing with innovation?
Yeah. Well, I think, fundamentally, the UK framework, through the Health and Safety at Work Act, which has been on statute unchanged for 50 years, says that you need to control your risk. I was paraphrasing a bit, but it doesn't really say much more than that, and that applies to all hazards. That is extremely outcome-focused and extremely goal-setting, goals to be achieved and not absolute standards to be met. Now, obviously, as I've mentioned, it's supplemented by other regulatory interventions, but the whole framework is firmly goal-setting, and a framework that also, in setting goals to be achieved, puts the onus on those who create the risk to manage the risk, to be active managers of their risk, to be given the freedom to do so and not be passive recipients of instruction from the likes of me, encourages developers and employers to think about their hazards and risks, to think about the technology, and to think about their approaches to risk management. That, again, helps us as a regulator on the innovation journey, if you like, to understand the developments that we can then come in respect of policy development and change.
Thank you. Anything to add briefly, Mike?
Yeah, just as these guys have said, innovation's kind of intrinsic to fusion and also other advanced technologies, especially like in the fission world. I mean, from a regulatory point of view, we need to engage with these innovations to ensure that we're given the right sort of input from a regulatory point of view. I mean, you talk about these kind of like sandboxing approaches or regulatory safe space where we can interact with the designers to give regulatory input. I mean, we have done it quite a lot over the last few years. Part of the Advanced Modular Reactor feasibility and development work, we've been interacting with Tokamak Energy to discuss their design. So we assessed their submission, and we've had a number of engagements to talk about developments in their design, where they've talked about, for example, their material irradiation strategy, and we've discussed that in detail. And that those sort of engagements are beneficial for us as the regulator to manage our risk, and also beneficial, I hope, for Tokamak Energy to understand our regulatory kind of views and opinions on their designs. So, yeah, innovation, we need to kind of work together. I mean, often when we ask a kind of a designer or operator to demonstrate their design, we're looking at, for example, operational experience or good practice. And when you're looking at innovation, that you're actually developing that as you're going along. So you need that interaction with the designers to take those baby steps in that sort of demonstration of best available techniques to get along the road and to enable innovation.
All right, well, thank you very much for those. We touched on a lot of areas about what our hazards are, how we're going to upskill the industry, looking at international engagements and enabling innovation. So I'd like to pass it over to questions. If we have some in the audience, there's a gentleman a couple of rows back first.
Hi, Sam Humphries with Mini Circuits. So we're an electronic component supplier who provide components for a range of industries, including aerospace and automotive. So in those industries, there are de facto standards that suppliers at our level, so tier 1, tier 2, need to show that we're meeting. That's sort of Automotive Electronics Council qualification, or that is MIL spec, ESA specification, and that's on the parts and on us. Do you see the fusion industry going down that kind of route, or will the regulatory compliance be placed on primes and OEMs?
Who'd like to take that one?
if I can just come in there from the workplace health and safety perspective, as I said in my last contribution, it's firmly outcome focused, it's firmly goal setting. We don't tend to use a great deal of prescription, though if you look at the various regulations that we do have in respect to the control of hazards, there is some prescription in there. There is a lot of goal setting in there. There are some technical standards to be met. So it is a mixed picture, but we do not tend to default to prescription. In fact, we could, as I've mentioned in one of my earlier interventions, just fall back on the duty to control risks as far as is reasonably practicable. But in supplementing, we tend to supplement through, a measured assessment of what is proportionate and appropriate to the risk, fundamentally. So as I say, goals, outcomes to be achieved rather than absolute standards to be met.
So Sachin, as part of the industry, it's often the industry itself that develops codes and standards. Is that perhaps what you could...
Excellent, yeah. I try to answer this in a couple different directions, but on the idea of using standards in power electronics. So we're actually a large procurer or developer of power electronics. And so those standards that exist already for specific devices or specific components are very useful because it tells us the capabilities. It's something to work off of. We may push these electronics to new levels, and as a result, we may, not abide by the standard or go beyond the standard in terms of capabilities because we need to for our device. But it's a good starting point, and so we definitely rely on them in that regard. We're actively involved, for example, with the American Society of Mechanical Engineers, which was one of the first industry associations to look at standards. And from my view as an individual developer, I think we're a little early for something that's kind of a hard, fast, and set traditional standard, because there's so much diversity in this field. There's so much still more to do, and one of the real advantages of a general standard like that is to facilitate kind of mass production and scale, right? So if you can give to a supplier, you're an OEM, and you give to a supplier this is just you meet this standard, right? Everyone else in the industry agreed on the standard, so produce this thing for me. If we're not at that level because we're figuring out how to make our first fusion devices, our first commercial devices, a standard will mostly inhibit or set goals that may not be tied to what a final product would be. However, I do think we should be thinking about that because at scale, that point, right, we quickly talk about getting our first device and then getting to our 100th device in a very short amount of time. At that point in time, I think, so end of the decade, start of next, you'll see the standards discussion come up a lot more specific to fusion. In the interim, we're very reliant on the standards for components that exist out there to help us baseline our technologies.
Thank you. There's a gentleman at the front here. Wait for the microphone to come down. Do we have the microphone down to the front, please? Thank you.
Hi, Faisal Mahad, Ofgem. I want to think slightly ahead and think maybe in 10 years or 20 years time when Fusion's grid ready. And I think I'd be interested to see what advice or you would have for what I would call second order regulators, or for lack of a better word, like Ofgem or the other energy industry regulators. What advice do you have for them in terms of the challenges that they might see in integrating fusion into the wider energy sector?
Who would like to answer, Richard?
I'd like to answer. I'm not sure if I could provide a particularly informative answer on that, and I might plead it as beyond my vires and maybe take it away under advisement, have a think about it, and see if there's anything we could advise on that through other forums. I'm sorry to be so blunt, but it is unfortunately outside of my competence, I think.
Anybody else want to?
I mean, please, don't say that's the final word of the panel.
I'm not sure I've got anything to add, to tell the truth.
So, as someone that doesn't speak for any regulator, I can then thus pontificate about what regulations should be.
Fantastic.
I think that I can only speak to the US regime, right? We have an alphabet soup of regulators, right, that'll apply to this technology. And so we have to think about, for example, the Federal Energy Regulatory Commission, which deals with interconnections. Or we think of the Department of Energy deals with import-export controls. The Department of Commerce is actually more apt for dealing with import-export controls. And we do think that as this we have to solve some key initial questions, such as the general regulatory approach for fusion, but that's going to happen within a year. At that point in time, I do think interagency collaboration, and something the US does do a lot of out of DC is interagency collaboration, will be very useful to say, okay, now that we're classifying fusion devices as a type of particle accelerator, an industrial facility, and developing a framework around that, what are the spillover effects onto export controls? Or how does that mean for interconnection requests onto the grid? And there, I think we'll have to have those conversations probably over the next 1 to 2 years to start spelling out how we're going to build an integrated energy system.
Thank you. I'll pick one from online now, because you just talked then about timing, so there's one that's quite relevant to that. It's a US-specific question, but I think it would apply to anywhere. Do you see a problem with the US Department of Energy moving forward with funding a fusion pilot plant before the regulatory framework is in place? Can we be confident that the regulations aren't going to handicap the program after it's begun, presumably by changing or making decisions?
I guess I'll take that one first. Since it's specific. I think, first of all, I would say that I'm not sure the DOE is going to. It's not building its own pilot plant. What I understand the DOE is doing is having a number of awards to support private sector entities to develop the first pilot plants. I don't think that's going to be a hamstring in any sense, for 2 reasons. One, the process will still take a while to develop that first pilot plant. We're still talking about a decade out, and the NRC has a goal to develop initial regulations for fusion in 2027. So we got some time there to develop that regulatory framework. And second, one thing the NRC has done a lot of is it's had this situation where as it's developing a rule, things come in that advance the rule. And so what you can do is you take the lessons you're building on. For example, you might have a proposed rule. You might have guidance you've already written, draft guidance. You use that to handle ad hoc license applications as they come in. So the agency is quite used to that. For example, the agency is, and going to something totally different, the agency has a licensing program for exports of deuterium that it's trying to figure out. We've been exporting deuterium for decades, right? And so it's able to use lessons learned as it's working on some of its export control regime updates to handle current cases of exports as they occur.
Thank you. Do we have any more questions? There's one in the middle there. There's our microphone. Thank you. We'll take this as our final question and keep our responses brief for you.
Hi, everyone. Malcolm Parry from Hogan Lovells. Thanks for the session. It's been really great. So my question is around harmonisation of international standards. And obviously the UK has taken a massively helpful step in clarifying that fusion is not fission and therefore not subject to a sort of separate standards, and the US is going on the same path. But the sort of the clarity around the international conventions isn't there yet, in particular when we're talking about the volumes of tritium that are potentially required. What sort of timescales and what steps are envisaged to make sure that that sort of harmonisation across the world, well, at least within the sort of convention space, is what are we looking at?
Would you like to take that? I mean,
quick response would be great.
Pardon?
Just a quick
very
response.
quick response. Yeah, I got a minute. Just a few weeks ago, we were in Vienna for a week talking to international regulators. So Richard and I were there. There's also Canada, US, Germany, and France, and the input from Japan and South Korea. So there was inputs about their regulatory approaches. We were looking at gaps and challenges in regulatory approaches internationally. So it's not really the harmonisation of the regulatory frameworks. It's more about the harmonisation of regulatory approaches. So we're discussing about what we need to think about, where we should be putting our thoughts, what we need to know, and how we can continue to engage and share knowledge. So that was the kind of the developments we were looking into. So it's those engagements with other regulators that will help us look at international designs, kind of share knowledge internationally, to kind of harmonise in that sort of way.
Yeah, well, I mean, if I've learnt one thing in respect to fusion, it's perhaps a brave person who puts a timeline on anything. And you know, God might love a trier, but I'm not going to try. What I will say, and I echo what Mike said, is that engagement has started informally through discussions between regulatory authorities, but now more formally within the International Atomic Energy Agency, and the UK and others are engaged in that. It's at the very early stages, but you know, we should expect to see over the coming months some output from the first IEA discussions, which then begin the process towards their expectations in time through whatever series they wish to put it in. But I wouldn't want to put any definite timeline, except to say it will happen in the coming period.
Thank you. Well, we have come to the end of our timeline for this afternoon and for the day here at the Science Museum before we have the wrap-up session upstairs. So we've heard a lot about technology, we've heard a lot about science, but there are a lot of supporting areas, those softer areas. Regulation is one of those, and it's fantastic to see that the industry is thinking about it and that we have the engagement with our regulators and the engagement between industry and regulators. So I'd like to thank our panel today. If you could